In this video, I'm going to show you how to compute the price of an option using the Black-Scholes method, which is the other method, right? We have two methods, the binomial and the Black-Scholes. The Black-Scholes is weaker than the binomial for the reason, for one single and a very important reason is the fact that the Black-Scholes method can only be applied to European options. It cannot be applied to American options, nor to options that have paid or are going to pay a dividend between the beginning and the end. So what's a European option? A European option is one that cannot be exercised until maturity. Okay, where American options can be exercised anytime before maturity and at maturity as well, of course. So the European options are more restrictive. So the Black-Scholes, again, can only be used for European style options where there is a beginning and an end, and that's it. So that means that we don't have to worry about all those different variations of the price of the stock moving up and down. We don't need to have that binomial tree. None of that. It's actually as simple as this complicated formulation. It's as simple as this complicated formulation. You see what you understand what I mean, right? It is simple because all you have to do is apply 3 or 4 formulas, and that's it. You don't have to build wild things on Excel. So you're going to need these components, and the first two components are D1 and D2. So over here I have an option. I have a stock that is selling for $77 with a we're looking at an option with a strike of 74. We have a risk-free at 4%. This is different than binomial. We have time. In this case is measured by years. Time is 1, so this is a European option for 1 year. If it's less than 1 year, it's easy. All you have to do is do fractions of a year. So if it's 6 months, it will be 0.5 instead of 1. Not a problem. And this will be the volatility of the stock annualized. Again, because you're using annual here, you also need to use an annual an annualized number down here. So let's say that that's the volatility, and again, you get the volatility from historical data for that specific stock. Okay, so you're going to compute D1 is the first one, all right, and you're going to get it from this formula. So just let's do it. All right, so the ln, the logarithm of the natural logarithm of the price of the stock plus, what am I talking about? Divided by the strike plus, parentheses, the risk-free plus, parentheses, 1/2, so I'm going to do 0.5, multiplied by the volatility, the variance, which I'm going to square, close parenthesis, times the time, which in this case is 1. Okay, I'm going to close the parenthesis, and now I'm actually going to put the whole thing inside of a new set of parentheses, because now all of that is going to be divided by, parenthesis, the volatility times the square root of the time, which is 1. Close parenthesis, enter. Okay? So that's D1. Now, D2 is way easier. So yeah, D2 is this whole thing all over again, but it's actually a formula that makes it all easier. Okay, which is this one down here. So D2 is just equal to D1 minus the variance times the square root of the time. So D2 equals D1 minus, be careful with your parentheses, the volatility, the variance, times the square root of 1, and close parentheses. Oh, okay, so you now have D1 and D2. Okay, you have those two pieces. Now with D1 and D2, you're going to use it to find the value of this option, of this call option, by using this other formula. All right, so we're gonna go here and let's start. This one is a little complicated, so pay attention. So the price of the stock, which is 77, right, S, times the normal distribution of D1. So you're going to do times the normal, and some Excel's a little different. So for me, for the one that I'm using, I need the normal distribution of D1 in this case, right? With a mean of 0, and is this one with the S in the middle, norm.s.dist. Okay, so I'm going to click on that one. So my Z is going to be D1, and I'm going to tell it that it's cumulative. Okay, this is a cumulative distribution. It's always going to be in that case. Close the parentheses. All right. Okay, that minus the strike, which is the capital E. Okay, you can read it here. Strike times the exponential of E, which is going to be exp to what number? Negative risk-free, negative R, times T. Close the parentheses. Okay, so I just did this piece right here, which is the strike times E raised to the negative R times T. And that is multiplied by the last term, which is the normal cumulative distribution of D2. So we're going to do it again. So, times the normal distribution with the S in the middle, okay, the norm.s.dist of D2, and we say that it's true because, comma, it's a true statement because it's cumulative. Okay, let me show you again. You put true for cumulative. And that's it. That's the price of this call option. You use using the Black-Scholes approach for a European style option.